Okay, class, good afternoon. So this is another topic in power plant engineering. So last meeting, we discussed about the performance of diesel engine. So the topic was presented in several parts. So by this time, we are now going to discuss variable load. Okay, so but before that, so let us first consider the load curves. So we're in this load curve. So this shows the variation of load on the power station with respect to time. So if we look at the diagram, so the load versus time diagram, so this is divided into here in the abscissa. So this is 24 hours. So equivalent to 1 day. So from 12 midnight to 12. Okay? So 12 midnight again to 12 midnight is equivalent to 24 hours. So by this time, we are, if we just look at the curve, so we will notice that the curve varies. Sometimes, like say for example, in between 6 to 8, the value of the load at this time is equivalent to almost 5 kilowatt. So if we look at now the 10, so that is 10 a.m. So that is equivalent to 2 kilowatts. So at 12 noon, the value is 4 kilowatts, and at 2, so that is equivalent to 2.6, and at 6, so that is equivalent to almost 7 kilowatts. And at 12, back to the original load at 12 midnight. So, the highest peak now of the curve is the so-called the peak load of the day. Okay? So, that is what is meant by a load curve. Okay? So, we have here the types of load curve. So, of course, we have the so-called daily load curve. So, what is this daily load curve? So, this is a load variation, of course, during the whole day. Okay? So, that is equivalent to 24 hours. And then we have also the so-called monthly load curve. So, this is a load curve obtained from the daily load curve. Okay. And then, equivalent to 1 month. Okay. So, we have another is yearly load curve. So, this is load curve obtained from the monthly load curve. Okay. So, we have here also the so-called base and peak load on power station. Okay. Base load. So, what is a base load? So, base load is the unvarying load which occurs almost the whole day of the station. Okay, so that is the base load, unvarying load. Okay, and then we have the peak load. So the various peak demands of the load on the station. So if we look at the daily load curve, the highest point of the curve is called the peak load. Okay. Now, so if we look at again this diagram, so we'll notice that this point is the maximum load. Okay, and then we have here the peak load, and then we have the base load, and we have also the so-called intermediate load. Okay? So the base load, of course, is the lowest load of the plant. Okay, so let us now take some terms and factors. Okay, so we have here the so-called reserve over peak. So before we go to the calculation of this topic, so let us first know what are those terms, definition, and factors involved in variable loads. Okay. So, reserve over peak, this is the plant capacity less the peak load. Okay, so of course, the capacity of the plant is always greater than the peak load. And the difference between the two is the so-called reserve over peak. Okay? Another is average load. Okay? So, average load from the definition. So, this is the ratio of the kilowatt hours of energy to the period covered. Okay? So, we have here also a factor. So, we call this as diversity factor. So, this is the ratio of the sum of the individual maximum demands of the various subdivisions of a system or part of a system to the maximum demand of the whole system or part under consideration. Okay? Another, we have the so-called demand factor. Okay? So, this is the ratio of the maximum demand of the system or part of the system to the total connected load of the system or part of the system under consideration. Another, we have load factor. So, the average load over the designated period of time to the peak load occurring in that period. Or the average load may be determined for any specified length of time such as day, month, or the year. Capacity factor. So, this is the ratio of the average load on the machine or equipment for the period of time considered to be the rating of the machine or equipment. So, when applied to the plant, this factor is called plant factor or plant capacity factor. So, class, it is very important to memorize or familiarize these factors. So, because without knowing this definition of terms and factors, it is very difficult for you to solve a problem in this topic. Okay? So, another, we have the output factor or the use factor. So, this is the ratio of the actual energy output and the period of time considered to the energy output which would have occurred if the machine or equipment had been operating at its full rating throughout its actual hours of service during the period. Okay? So, that is called use factor. So, another, we have the so-called utilization factor. So, this peak load was already described in the previous slides. Okay? So, peak load, meaning the highest curve of, okay, in a curve rather. Okay? So, another, we have the utilization factor. So, the ratio of the maximum demand of the system or part of the system to the rated capacity of the system or part of the system under consideration. Okay? Connected load on a system or part of a system. So, this is the sum of the continuous rating of the load consuming apparatus connected to the system or part of the system under consideration. Okay? Another is we have the so-called operation factor. So, this is the ratio of the duration of the actual service of a machine or equipment to the total duration of the actual service of the machine or equipment to the total duration of the period of time considered. Okay? So, we have also the so-called damp power. So, what is a damp power? So, it's hydropower in excess of load requirements that is made available by surplus water. Okay? Another, we have also the so-called firm power. So this is the power intended to be always available even under emergency condition. This is always available. Okay? So another, we have the so-called prime power. So this is the maximum potential power constantly available for transformation into electric power. Transformation. Okay. Into electric power. Another, we have the called reserve. So is that reserve generating capacity available for a service but not in operation. So, but not in operation. So, but it is always available. Okay? Another, we have the hot reserve. It's the reserve generating capacity in operation but not in service. So, the hot reserve is now operating but not in service. Okay? So, that is called hot reserve from the word hot. So, meaning it is now in operation. Okay? So, another, we have the reserve equipment. So, this is the installed equipment and excess of that required to carry peak load. Reserve equipment not in operation is sometimes referred to as standby equipment or reserve equipment. Okay? So another, we have also the so-called spinning reserve. So in the previous slides, we have the so-called hot reserve. So what is this? So this is a reserve generating capacity connected to the bus and ready to take load. Okay? System reserve is the capacity. Okay? And equipment and conductor installed on the system in excess of that required to carry the fake load. Okay? So another definition, we have run-off river station. So this is for a hydroelectric power plant. Okay? Another is spare equipment. Okay? Equipment complete or in parts or hand for repair or replacement rather. Okay? Generating station, auxiliary power. The power required for operation. Okay? Another, we have the base load power plant. So, base load power plant include steam, hydroelectric, and geothermal power plant. So, the base load, of course, are those plants which are very sometimes there is a complication in starting that plant. Okay? So, starting is much complicated. Unlike in diesel power plant, so once the engine was started, of course, it can easily generate power. So that is why diesel power plant is utilized for peak loadings. Okay? So peak load power plant include diesel, electric, and gas turbine power plants. Okay. So generating station, auxiliary power. So what is this? So it's the power required for operation. Okay. Another, we have the so-called availability. So it is the fraction of the time a plant is available for generation. Sometimes a plant may be partially available due to lack of operation for some components of the plant. So it is called partial availability. Okay? So another is outage. So it is another term for the shutdown of the plant either for plant maintenance or due to unforeseen breakdown, okay, or forced outage, okay? So we have now reserve or the average load equation. So let us now identify the average load equation, or what are the formula that we are going to use. Okay? So for daily average load, so this is equal to the number of units that is in kilowatt hour, or this is the energy generated in a day. Of course, divided by the number of hours per day, which is equivalent to 24 hours. Okay, so for monthly average load, so that is the number of units or energy generated in a month divided by the number of hours per month. Okay, so number of hours per month. And for yearly average load, that is number of energy generated in a year divided by the number of hours per year, which is equivalent to 8,760 hours. Okay? And the average load is area under the load curve divided by the duration of the load curve. Okay? So that is the general equation for the average load. Okay? So reserve over peak, of course, is the difference between the plant capacity and the peak load. Another, the equation for diversity factor. So diversity factor is the sum of maximum individual demands divided by maximum demand on power station. Okay? Or for several line connected, that is also equals to, so the maximum at line 1 plus maximum at the another, and the maximum of the other divided by the maximum simultaneous demand. So that is equal or greater than 1. Take note of that. Okay? So that is for diversity factor. So demand factor, that is, demand factor, of course, we have the maximum demands divided by the connected load. Okay? So that is less than 1 or equal to 1. Okay? So load factor, we have also the average load and maximum demand. Okay? So take note. So the formulas involved in variable load are very abundant. Okay? So a plant is in operation for 3 hours, of course, the load factor, average load times time over the maximum demand divided by the time. Okay? So, capacity factor. So, the capacity factor or plant capacity factor is equal to actual energy produced divided by the maximum energy that could have been produced. Take note, this is, again, less than 1. Okay? So, another is the output factor or use factor. So, here is now the equation. So, plant use factor equals to station output in kilowatt hour. This is energy divided by the plant capacity multiplied by the number of hours used. Okay? Or used. Another is the utilization factor, that is equal to maximum demand of the system divided by the rated capacity of the system or plant. Okay? Another is the so-called operation factor. So this is equal to duration of actual service divided by the total duration of the period of time considered. Okay. So those are the formulas or definition of the factors involved in variable load. Okay, so let us now consider an example. So in order for the formula or formulas to be applied to the actual situation. Okay, so let us now consider this problem. So from a 50 megawatt diesel power plant, the following data were obtained. Annual gross kilowatt hours generation is equals to 246 times 10 raised to 6 kilowatt hours. Annual net generation is 231 times 10 raised to 6. The annual operating hours generation is 7,734. So this is less than 8,760. The annual average load is 31,890 kilowatts. Annual maximum peak load, 48,000. And the fuel oil consumed is 18,364 times 10 raised to 6 gallons. And then calculate, okay, annual load factor. Next is the annual plant capacity factor. Another, the annual plant use factor and gross fuel economy in kilowatt hours per liter of fuel. Okay. So let us now solve for the load factor. So load factor is the average load divided by the maximum demand. Okay? So if plant is in operation for 3 hours, that is load factor, equals to average load times time over the maximum demand multiplied by time. So by this time, so we already given. So the average load multiplied by time and the load factor. Okay? So that is 31,000 over 48,000 is equivalent to 66.44%. So that is now the load factor of the plant. Okay? So another, we have the plant capacity factor. So the plant capacity factor, that is equal to the actual energy produced divided by the maximum energy that could have been produced. Okay? So that is equal to 231. So it's already given. So times 10 raised to 6 over 50 times 10 raised to 3 times the number of hours per year, which is 8,760. So that is now equivalent to 52.74%. Okay? So another, we have the annual plant use factor. So again, so the definition is equals to maximum load over rated capacity of the plant. Substituting the values, and then utilization factor is equivalent to 59.74%. So for the gross fuel economy now, so in terms of kilowatt hours per liter of fuel, so that is the energy gross generated divided by the fuel consumed. So that is equivalent to 246 times 10 raised to 6 kilowatt hours divided by 364 times 10 raised to 6 gallons. Okay, so converting now gallons to liters, so that is now equivalent to 3.539 kilowatt hours per liter. Okay, so meaning for every liter of fuel consumed, the generated energy is 3.539 kilowatt hour. Okay? So another example. So we have here, power plant is said to have a use factor of 48.5% and a capacity factor of 42.4%. How many hours did it operate during the year? So if you just look at the problem, determining the time the power plant operates in 1 year is, I think, difficult. Okay, so but knowing the equation, use factor is equals to energy, or the actual energy produced divided by the capacity multiplied by the number of hours in operation. Okay, or per year rather. Okay, So the capacity factor now equals to E over capacity of time or times 8,760, or getting now the number of hours in operation. So substituting the use factor and capacity factor. Okay? So rearranging the equation and then getting the value of H prime, or the number of hours the plant operates in 1 year, that is now equivalent to 7,600 or 658.23 hours. Okay? So, it's clear. Another example. So, a 75 megawatt power plant has an average load of 35,000 kilowatt and a load factor of 65%. Find the reserve over peak. Okay? So, knowing the reserve over peak equal to plant capacity minus peak load. Okay. So, and then getting the load factor. So, the peak load now becomes 53.85 megawatts. Okay? So, since we have now the given of 75 megawatt power plant, so subtracting 53.85 megawatts, the reserve over peak is 21.15 megawatts. Thank you very much.